Sorry, I reached the free limit, 15-minute limit, so I'm going to finish this up. Okay, so that would just be negative 3 over 24, which simplifies to negative 1/8, multiplied by the reciprocal d theta dt. So that angle would be changing, so that would become 2 over 8, and then the root 3 in the denominator, which simplifies to 1 over 4 root 3. If you got the, I think I was really confused because I was, that's the answer. That's that many. It's, remember, we're in radians per, what was this in? Per minute, okay. If you wanted to get the square root of the denominator, I believe it would be root 3 over 12 radians per minute is equivalent. So either answer. Some might say that one was better because you were taught to do it that way. Get the roots out of the basement. So in science class, you you got your dropper, right? Dropping blood from a pipette into a circle on a slide. Okay. And it's spreading, like when you drop it starts spreading. So how fast is the radius of the drop? Okay, so whose area increases, so we know that the area is increasing at a constant rate of 2 square millimeters per second. How fast will we want to find? How fast is the radius of the drop increasing over time when the area is 6 square millimeters? Okay. Well, this is going to be area of a circle. Area equals pi r squared. Let's derive both sides with respect to t. I'll get dA dt on the left equals, I can put the pi over the front, be 2r dr dt. So I think I have everything I need to plug in here. I have the dA dt. Well, the thing is, they gave me a, but not r. Well, we know a and r are related in this equation, so why don't I just figure out what the radius is of a circle whose area is 6. So I could do 6 equals pi times that radius squared. 6 over pi, the square root of 6 over pi would be r. So I could plug that in for r. dA dt, they told us, was 2 pi 2 times 6 over pi, and then times dr dt, which is what I was trying to find. How is the radius changing? So divide by 2, that would just be 1, divide by pi, I would get 1 over, well, actually, what might be better would be to do this. I could divide by 2, I'll get 1 over here if I divide that 2 out. And then I get pi times, maybe I'll split this up to root 6, and then this will be root pi, or pi to the 1/2 power. Or that would just be pi to the first. I could subtract to cancel that out, so this would be pi to the 1/2, or root pi in the numerator. So, or root 6 pi. I'm going to have to do that, but I think I have ended up doing it, because then it's a little cleaner. So, dr dt would just be equal to 1 over root 6 pi. If you want to get the roots out of the basement, you can multiply it by root 6 pi over root 6 pi, which would just give me root 6 pi over 6 pi. And that's how the radius is changing. that many millimeters per second. And oh, they just left the text, or not the textbook, they just left it like this. I mean, it is kind of but it's the same numerically. Hope these videos were helpful. I know these problems can be a little tricky, but once you get in the hang, it can be kind of fun because you have to think about how to relate the rates, related rates problems. Much love, everybody. Have a great day.